All right, we're doing section 13.8, and I think we have one more section of trig stuff, and then we still have to jump back. Remember, we skipped 2 sections. I think, forget the numbers, 5 and 6, 6 and 7, or 5 and 6, 4 and 5, I don't know. Well, anyway, sine and cosine, law of sines, law of cosines, we're going to hit that as soon as we finish this next thing, all right? So I wanted to keep all the trig together. They kind of put the law of sines, law of cosines kind of in the middle of everything. I don't know if they wanted to give you like a little break from all the trig stuff, but I just thought just doing all the trig stuff all at once would be a little bit better. Okay, here we go. Remember we did stuff like this. We graphed this, right? And what did that, you look at it, that's the parent function, we've mentioned that. And what is the basic shape of that thing? It's a V, right. Now what if we did this? We're not going to graph it, but what if we did this to it? What did that do to that graph, to that V? Moved it to the right 2 places when it's part of the function, okay? When it's part of that x, when it does something to that x, and it's inside that absolute value right there, that's the function, is it? The absolute value. So when that minus 2 or plus 2 or whatever the number is, when it's inside the function itself, in this case the absolute value, you move it in the opposite direction. We discussed way back when we did this, excuse me, why we moved it to the right. I think we did, plotted some xy charts and just threw the numbers in, and we saw that we may think that it goes to the left. You're just looking at it, it's a minus, obviously minus kind of means left, but we actually move this to the right 2 places, okay? And what if we did this? What if we stuck a number on the outside of the function? What does that do to our graph, to our V? Moved it up. So basically this moved it to the right 2 places and this moved it up 3 places. We did the same thing. We talked about parabolas, right? So we said, what's this? Like if we did that, what does that plus 5 do to that parabola? Moves it to the left 5 places. What does the minus 1 do? Moves it down, okay, 1 place. Do you follow me on that? Well, the same thing holds true with the trig functions. Let's just get rid of that. That was just for fun. All right, so the same thing holds true with the trig function. Now, we've already played around with those trig functions a little bit. We've changed the period, right? And we've changed what? The up and down. What was that called? The amplitude. So we've changed that. We already know what that does. So our formula was y equals a, and we'll just use sine of b theta, right? So the a changed the amplitude. Now the b isn't necessarily the period, but it changed the period though, right? That number changes the period. And how do we find the period? 360 divided by b. By the way, I've been going on a lot of websites where teachers teach like this, and almost everybody to a person is doing stuff in radians, all right? But most of those classes are pre-calc classes. When they label it, they call it pre-calc. They're doing the same kind of stuff, but they do everything in radians, all right? So again, I just want you to be aware that people use radians all the time instead of degrees like we've been using. But I think we'll just still stick with degrees just because it's a little more intuitive, right? But just remember that eventually you will have to be able to do this stuff in radians, which it really isn't that big of a deal after you get used to it. If I said pi over 2, what's pi over 2 in degrees? Pi over 2 radians, what would that be in degrees? It'd be 90, right? So instead of saying 90, they say pi over 2. Instead of saying 180, what would they say? They say pi. No, 180 is just regular pi. Okay, you follow me on that? It's really not that hard to get used to, but for now we'll just stick with degrees. Is that okay? All right, but I just want you to realize that later on you're going to see stuff like that. All right. First thing we're going to do is talk about how to move this thing left and right. So let's forget, let's say the amplitude is 1. Let's say the period is 360. So the b would be what then? If the period was 360, it'd be 1. Okay, so let's just start off really basic. So this is your basic parent function of the sine. Now, what in the world would I do to move this left and right? Well, this is how they show it. They would go like this. The sine of, sometimes they use different letters, theta. Now if I moved it to the right so many degrees, what do you think I would do here? I'd put a minus, right? And they use the letter h here, okay? And that represents how far, either left or right, it goes. So if it was a minus a certain number, then it would move to the right. If it was plus a certain number, obviously it would move which way? To the left. Okay, does that make any sense? All right. So that is a thing called the phase shift. That's what we call it. All right. So that's the phase shift. That moves it either left or right. A certain number of degrees, because you're changing theta. Do you see that? So you're moving it along the x-axis. And what is the x-axis? The x-axis is in degrees for the most part, right? Again, sometimes they put it in radians. But for what we've been doing, we've been keeping everything in degrees. So that moves it either left or right in degrees. Now, what do you think would move this thing up and down? Because we can move that whole graph and take it and pick it and move it up or move it down, couldn't we? So what do you think you're going to do here to move it up or down? Just add something at the very end. That's right. Notice, this h dealt with the function itself, the theta. Do you follow me? It changed the x value. Now, sometimes people will write x instead of theta in this situation, and that's fine. It just means basically the same thing. Because theta's been along our x-axis, hasn't it? All right, so I don't want you to get confused if you see it written another way. It means the same thing, okay? And then, plus, I think they use the letter k. Let me see. Where are we? Oh, it's the other page. Yep, they use K. That's what I thought. All right, so they use the letter K to move it up and down. All right, so what's happening here? This tells you how far, and this they call this, I think they call it a vertical shift. All right, so this is called the phase shift, which basically is horizontal. I guess they could call it horizontal shift, but I've always learned it phase shift, so that's what they said too. And this moves it vertically. All right, so they call this a vertical. Or I think when we did the absolute value and the parabolas, you know, the x squared functions, I think we just called it a vertical translation. So you could call it that, well, that as well. Translation just means move it up and down or left and right, but they call this a shift, so we'll just call it a shift. All right, so vertical shift, and this is the phase shift. This moves it left and right. This moves it up and down. You with me? So now, let's put it all together. Let's put the A and the B and the H and the K, put it all together, and so that we can see what we have. So we have what? A, and again, we'll just use the sign of theta minus H. What's that? I sure did, didn't I? Yep. Thank you. All right, yep, I forgot the B. So B theta minus H plus K. All right, so that is your basic, equation of a sinusoid, of a sine curve. And you know what all this stuff does now to it, don't you? You know that that thing right there moves. It stretches it out vertically, doesn't it? Okay, it doesn't actually physically take the graph and move it up. It just takes it and stretches it up and down. That's the amplitude. The B stretches it how? If this stretches it vertically, this stretches it what? Horizontally, right? That's the period. Isn't that basically what the period's doing? Is stretching it horizontally? Yeah. Either squishing it, right? Or it's stretching it out, all right? This right here is the phase shift, and the phase shift just represents actually picking it up, not stretching it, but picking up and actually physically moving it left or right. You follow me on that? That's what it's doing. And then the K actually physically picks it up and moves it up or down. And again, what does this do? This stretches it. The A and the B stretches it, either vertically or horizontally. The H and the K actually picks it up and moves it left or right, or in this situation that the K moves it what? Up or down. Does that make sense? Okay. Well, let's do an example, and let's see what we can do with this, all right? And we're coming to the end of our time, so let's go to the next.